Okay, now I want to talk about the proper way to write a weak base, strong acid neutralization reaction. I'm going to use B to represent any weak base, and I'm going to, of course, be reacting it with a strong acid. The strong acids are all going to be completely dissociated in solution, giving us H plus and whatever the anion is. So since I'm trying to write a net ionic equation here, I'm just going to use H plus as the strong acid. I'm not going to represent the anion or anything. And then I'm going to use a straight arrow because these things essentially go to completion, and stick the H plus on the weak base. It's as easy as that. Okay, so that's kind of generic. Let me do this for a few actual weak bases. If I'm talking about a weak base like ammonia, I would react it with a strong acid and form the conjugate acid, ammonium. If I'm talking about a weak base like fluoride, I would react it with H plus and form the strong acid HF. If I'm talking about a weak, did I just say strong? I meant weak, obviously. HF is a weak acid. It is the conjugate acid of the weak base fluoride. If I'm talking about a weak base like hydrogen phosphate, which I know in the last video I dealt with the way hydrogen phosphate acts when you treat it with hydroxide. It acts like a weak acid, but when I add H plus, it's going to act like a weak base. It's going to accept that hydrogen plus and form H2, this was a -2 charge, H2PO4 minus 1. Okay, so what do all of these have in common? They're all balanced as to both mass and charge. One boron, one hydrogen, that's balanced as to mass. This here I'm representing the weak base as neutral, but of course the H plus is always +1, and the conjugate acid on this side is +1. The conjugate acid is always going to look just like its weak base counterpart, but with an H plus on it. Here, ammonia is neutral. H plus, of course, is +1. Ammonium is +1. For this next one, fluoride has a -1 charge. Hydrogen has a +1 charge. So the whole left-hand side here adds up to 0. HF is neutral. HF, the weak acid, is always going to have 1 charge higher than the conjugate base. And then finally down here to hydrogen phosphate. Hydrogen phosphate has a -2 charge, but of course H plus has a +1 charge. The entire left side here adds up to -1. Dihydrogen phosphate has a -1 charge. Okay, these are pretty straightforward, and these are most definitely easiest to write if you just go straight to net ionic. All you're doing is sticking an H plus onto whatever the weak base is. Hope this helps.